Well, greetings, Mr. Kolazar's class. Our last section of acids and bases deals with buffers. So section 18.4 or 18.14 is going to be on buffers, and we're going to look at the properties of buffered solutions specifically versus unbuffered solutions. Now, buffers are solutions that can resist the changes in pH when acids and bases are added. Now, the idea would be is if you were to be given a solution and it had a pH of, say, 6 to begin with, and if you were to add either acid, so if you added some acid, it would lower it, or if you added some base, it would increase it. And if it was strong, it would do that very dramatically, so we could have a lot of decrease or a lot of increase in that pH. Now, if we add a buffer, it's going to resist a change in pH, and it's going to stay right around where it was supposed to be instead. So we'll have very little change. Now, our components of a buffer are going to be a weak acid and its conjugate base, or a weak base and its conjugate acid. And we're going to look through to see about those two parts and how they actually work to buffer the solution. So we're going to start out with a buffer that's made of a weak base, or it's going to be a weak acid, and a conjugate base. Now, sodium here isn't really used in this reaction. It's a spectator. So we're going to kind of just leave it out. And then the rest of this is our conjugate base. Now, if we were to take hydrochloric acid, which is a strong acid, and put it into a solution that had our buffer from up above, as the buffer is added, it's going to react with the conjugate base. Or Cb. And so what's going to happen is the HCl is going to react with that C2H3O2 minus. And we really don't even care. The CHCl is also a spectator. In this reaction, it just isn't solution. So the H plus is going to react with that conjugate base, and we're going to form. So we're going to go from HCl, a strong acid, to CHC2H3O2, which is one of our weak acids. And with it being a weak acid, very little H plus is produced, and so very little pH takes place or changes. So we're looking at resisting that change. The other example we have is if we were to use a strong base. And in this case, the strong base is going to react with that weak acid. So we're going to look at, as one is added, it's going to react with that weak acid. Now, as it reacts with that weak acid, NaOH is going to react with H2H3O2. And as it reacts, the OH and the H are going to react to form water, and then the rest of our reaction is going to go to completion, and that sodium, a spectator ion, really isn't involved, and we're going to go from having a strong base to a weak conjugate base. So in both cases, buffers are helping us to lower that change or decrease that change in the pH by going from a strong acid or base to a weak acid or base. Why these are important, remember, resist the change in pH is our key part. So when an acid or base are added, a big example important to us is our blood must maintain about a pH of 7.35 to 7.45. So if acids or bases are added, they buffer so that we keep the regular pH maintained for our biological functions in our body. Buffers resist our pH change.